Hello students, today we will study one of the question, that is of exercise 6.3, question number 2, sub question number 3. This is the topic of standard 10, chapter number 3, pair of linear equations in two variables. So this is the question in the category of equations reducible to pair of linear equations in two variables. So from this given question, first of all, we will derive two equations, but we know that now that equations are not in the linear form. So we then convert that two equations in the linear form, and from that we find out our variables value, that is asked in the question. So what is the question? The question is, Ruhi travels 300 km to her home partly by train and partly by bus. She takes 4 hours if she travels 60 km by train and the remaining by bus. If she travels 100 km by train and the remaining by bus, she takes 10 minutes longer. Find the speed of the train and the bus separately. So two things that we have to find out here is the speed of the train and the speed of the bus. So let's suppose, we will suppose that the speed of the train is x km per hour and speed of the bus is y km per hour. Okay. So from the given question, there is two situations. First situation is Ruhi travels 60 km by train and remaining by bus in 4 hours. So let's suppose this is the total of 300 km distance and this much of distance is 60 km. So how many remains if she travels 60 km? Out of 300, if she travels 60 km, remaining distance is 240 km. And here is given the question that remaining distance she travel by bus. So this 240 km distance is travelled by bus. First 60 km distance is travelled by train, right? And how many time? What the time given is 4 hours. In 4 hours, she complete the total traveling starting from 0 km to 300 km. So now based on that we have to make an equation. So what we have is, we have the speed of the train and bus, we have the distance. Now according to the formula of speed is equals to distance over time. Here two things we have given, one is 300 km and one is 4 hours. So we can make the formula by taking one of the quantity either by distance or by time. But if we make the formula from the distance by taking distance here, speed multiplied by time. So what we will get? The speed is x and the time, here we need time, but time is not given, that in how many time, in how much time it will take if we travel by the bus or by the train. So there is no time. So what we have to use now, the second quantity that given in the question is time. So if we here make the time as an subject, then what will happen? Time is equals to distance over speed. We have distance, yes, we have the distance 60 km and 240 km. Do we have the speed? Yes, we also have the speed x and y. So now based on the time we will make the formula. So to make the equation from both the side, left hand side and right hand side, what we have to put? The time. But the time is also in the hours. So let's suppose to travel by train 60 km, she takes T1 time, and to travel by bus 240 km, she takes T2 time. So the total timing is 4 hours. So the first equation is T1 plus T2 is equals to 4. Now what is T1? That is the time. And what is the time? Time is equals to distance over speed, right? let's suppose this is the T1 is the time taken by the train, right? So here we have to take the distance traveled by the train, and that is 60 kilometers, right? And the speed of the train is x. So the time taken by the train to cover 60 kilometer distance is distance over speed, and that is equals to 60 upon x, right? So this much hour is taken by the train to cover the 60 kilometer of the distance. Now here for the same, for the bus, to cover the 240 kilometer, how much time it takes to cover the 240 kilometer? Again the time is equals to distance over speed. Distance is 240 kilometer over speed. Speed is now y, right? So this is the time taken by the bus to cover the 240 kilometer. So what is this? This is the time. This is also the time. Both the times in hours, and right hand side also this is the time in the hours. So in this way we make the first equation. 60 upon x plus 240 upon y is equals to 4. Right? Remember one thing, whenever you make this type of equation, both the side of left hand side and right hand side, the quantity should be equal, or the quantity, that means if you have taken the hours, then both the side it should be hours. If you have taken the distance, then both the side it should be distance. Okay. What is the second situation? Second situation is, if she travels 100 km by train and remaining by bus, then she takes 10 minutes longer. 10 minutes longer. That here you have to understand 10 minutes longer. But for what time longer? The time taken in the first case. In the first case, she takes 4 hours. So this time she takes 4 hours plus 10 minutes. That is why it is given 10 minutes longer. Remember one thing, we just do not have to consider the total timing as 10 minutes. The total timing here is 4 hours plus 10 minutes. Right? So now again we know that this much distance, first distance covered by the train is how much here given is 100 kilometers. So the remaining distance is now how much? 200, because total distance is 3 kilometers. So 100 kilometer distance is covered by train and 200 kilometer distance is covered by the bus. Now time, here we have to take the time. Again this T1 is the time taken by the train and T2 is the time taken by the bus. So the time taken by the by the train is distance over speed. According to this formula, time is equals to distance over speed. Distance is 100 km and speed is x km per hour. For the same, remaining 200 km is distance covered by the bus, and this is y is the speed of the bus, and that is equals to, now the total timing is 25 upon 6 in hours. How to calculate this timing? Total timing we have is 4 hours plus 10 minutes. So we have to convert this 10 minutes into hours, and we add both these hours. That is why we get the total timing. So see, 6 minutes is equals to 1 hour. So 10 minutes is equals to how many hours? So 10 upon 60, we will get 10 multiplied by 1 upon 60. So 10 upon 60, that is equals to 1 upon 6 hours. So the timing of 10 minutes now converted into the hours, and that is 1 upon 6 hours. Now add it with the 4 hours. So the total timing is 4 hours plus 1 upon 6 hours. 6 is the LCM, so we have to multiply 4 with 6. So we will get 6 was 24 plus 1 divided by 6, and that is 25 upon 6 hours. And that timing is written here. Again both the side, this is the timing and these both are the timing in hours. So in this way we make two equations, right? But these two equations are not in the linear form. So we have to reduce these two equations into the linear form. To do that, see here, two equations I have written again. 60 upon x plus 240 upon y is equals to 4. First equation, 100 upon x plus 200 upon y is equals to 25 upon 6. Now let's suppose 1 upon x is equals to a and 1 upon y is equals to b. So here one thing we have to do is this 6 we can take into the numerator because right hand side is in the denominator. So this 6 is it will, if we take to the left hand side, it will goes in the numerator and multiply both these terms. So this becomes 100 becomes 600 and this 200 becomes 1200, right? So this will become 600 upon x plus 1200 upon y is equals to 25. So now applying this both things, first equation becomes 60a plus 240b is equals to 4. Give it equation number 1. And the second equation becomes 600a 1200b is equals to 25. Now we can see here that we want to eliminate a variable. So what we have to do here, coefficient is 600 and coefficient of a is 60. We have to multiply equation number 1 with 10 and subtract equation number 2 from this. So by multiplying this with 10, we will get 600a plus 2400b is equals to 40. And second equation remains as it is. But as we are subtracting it, we have to change the sign of all the terms because all are positive. So now all terms becomes the negative. So this 600a plus and 600a minus will cancel out each other. 2400b minus 1200b is 1200b and 40 minus 25 is 50, right? So by taking this 1200 to the right hand side, it will goes in the denominator of 50. So b is equals to 15 upon 1200. By cancelling the common factor, we will get b is equals to 1 upon 80, right? So because 15 8s are 120, that is why it will gives the 80 answer, 1 upon 80. To find out the value of variable a, now we will put this value in equation number 1. So here 60a remains as it is plus 240, instead of b we have to put 1 upon 80, that is equals to 4. So now if we cancel out this 80 and 240, we will get 18 3s are 240. 60a plus 3 is equals to 4. Take this 3 to the right hand side, it will become 4 minus 3 is 1. So 60a is equals to 1. So what is the value of a? A is equals to 1 upon 60. Now what we have, suppose 1 upon x. 1 upon x is a and a is 1 upon 60. So we will get the value of x is equals to 60. What we have, suppose 1 upon y. 1 upon y is b and what is b? b is 1 upon 80. So we will get the value of y is equals to 80. Now remember what we have supposed x and y. We have supposed that speed of the train that is equals to x and it is 60 km per hour, and the speed, what is y? Y is the speed of bus and that is 80 km per hour. So in this way we can solve this type of questions. Okay, thank you.